Good afternoon.
Good afternoon, sir.
Good afternoon. Let us wait for 2 or 3 minutes so that others could join. Okay, so in a minute or two, like 2 at 2 o'clock and 5 minutes, 2:05 will start. So should we start? Anyone?
Yes, sir.
Is it visible to you, the screen?
Yes, sir.
Okay.
Yes, sir.
So today we are going to start our module 4. In syllabus, this module is given a duration of 4 hours that we have to complete in 4 hours. So I think that we can complete the 4th module in this week. And also I am planning to keep your missed practical on Saturday. I will notify the time on Moodle Okay, as has any teacher announced that he will take on Saturday so far?
No, sir.
Okay, so if you remember, we had a brief encounter with cam and follower mechanism when we were learning the types of kinematic pair. Okay, there we had a glimpse of cam and follower mechanism. Now today uh, we will learn it in detail in this fourth module. Okay, uh, excuse me for a minute. I will close the windows first. It is making noise. Okay, so let us start with what is a cam and follower mechanism. So if you remember this diagram, you will recall that where we have discussed this concept cam and follower. So how this mechanism works? Basically, a mechanism is used to transmit or convert motion from one element to another element. So same way here, this is a cam. This is a cam which has got some sort of shape, okay, uh, which is according to its function or according to kind of motion it is going to impart to the follower. Okay, so what happens? This is a cam element, and over this element, one another element is in direct contact. Okay, so because of that, what will happen as this cam is mounted on shaft? Okay, when cam will rotate, when it will turn about this axis, as this follower element is in contact with the cam surface, the follower will reciprocate like this. Okay, so here cam is the input element and follower is the output element. Output is given to the follower. Okay, so one can easily say that with this cam and follower mechanism, we are converting the rotary motion into the reciprocating motion. Okay, so now we can define a cam as a rotating machine element which gives reciprocating or oscillating motion to another element known as follower. So reciprocating motion means you know that motion is taking place in linear path. Path of the motion is linear. Okay. But in oscillating motion, what will happen? That follower will oscillate. Okay. Say about some point O in this way. It will swing. It will oscillate about this point like this. So that is also one kind of motion which can be achieved using the cam and follower. Okay, so in this cam and follower, there is a line contact between follower and cam. यहाँ पे जो दोनों का contact होता है, okay, there it is a line contact, not the surface contact. Okay, because of that, it is a kind of higher pair. If you remember the classification of kinematic pair into higher pair and lower pair. So what was the basis of classification? Whether the contact between two element is of point type, line type, or surface type. If it is a point or line type contact, we called the pair to be a higher pair. So in same way, you can say a cam and follower constitute a higher pair. Okay. Now you can imagine the simplicity of this mechanism. Okay. In other mechanism, what happens? You know that in slider crank mechanism, there is crank which is connected to the connecting rod. Then connecting rod is connected to a slider. Okay, and this crank is connected to the shaft. So to transmit the power or to convert this rotary motion into reciprocating motion, you need number of links. But here you are doing it with just the help of two members. Okay, so that's why cams are widely used. Its applications include the operation of inlet and exhaust valves of IC engine mechanism. Okay, you know that in an IC engine mechanism there is inlet valve, so that the fresh mixture of air and fuel will enter into the cylinder. It will burn, will be converted into gases, and to force those gases out of the cylinder, you need exhaust valves in the engine. Okay, so to operate this valve means to open and close this inlet and exhaust valves, we use this mechanism, cam and follower. One video is also available with me of the same, which I will share with you. Next is automatic attachment of machineries. Okay, there means in order to automate the different processes, cam and followers are used. They are also find application in paper cutting machines, spinning and weaving textile machineries, feed mechanism of automatic lathes, etc. So I will show you its a video so you can have a clear idea. Can you see it?
Yes, sir.
This video is visible to you?
Yes, sir.
Okay. So see here, this inlet, these are the inlet and sorry. So this is the inlet and exhaust valve. Okay, what are they used for? To take the fresh mixture of air and fuel inside the cylinder, they will burn it, and exhaust gases will be out from other valve. Okay, so how these valves are operated? You can see this. This is the camshaft. This particular is the camshaft. Different cams are mounted. Okay, so when they rotate like this, see. the shape of, depending on the shape of the cam, the valve will be opened and it will be closed automatically. Okay, it is so timed that the at the right time, at the proper time, see, the mixture comes in. Okay, then after that it gets closed because of this shape, because height is not here, and after it gets expanded, the when gases has to go out, then exhaust valve will open. Okay, which will be operated from this cam. So I hope that you get the application. So this is one project which is developed on the basis of cam and follower. Here they are, you can find the cam. Cam has got particular shape. It is circular only, but it is eccentrically mounted with the shaft axis. Shaft axis and cam axis are not concentric. Okay, so I hope you get the idea of it. Now let us start with this is still running. Okay, are we back on presentation?
Yes, sir.
Okay, so it is about the introduction. Let us go to the next. Now, classification of followers. So there are different bases on which these uh, followers are classified. First one is according to the surface in contact. Okay, so where,
आता जा नंतर एक चल निघ. मी कशी कशी बसले हे करायचं.
okay, so it is the cam and a follower is in contact. So say it is the follower. So when where these two have contact with each other, if this surface is in the shape of knife edge, knife edge like this, and as it is touching the surface of the cam, then it is called as knife edge follower. So in this case, what happens? Sliding motion takes place between follower and cam. Because of sliding motion, excessive wear happens. Okay, of cam and follower. Mostly, follower will wear because we would like to replace it, but cam is made hard. Then there is, in order to overcome this limitation, there is roller follower. Okay, so I will show you the diagram. So here you can see that it is a knife edge follower because the contact point, there is a sharp knife edge present. Okay, in order to reduce the wear and tear problem, generally a roller is provided at the end of the follower. Okay, so what will happen that when cam will rotate, this roller will roll over the cam surface. Okay, but the motion of follower will not be affected. It will only be the reciprocating motion. Okay, now because of the rolling motion, instead of sliding motion, friction gets reduced considerably. Okay, it is the advantage. Then there are flat faced or mushroom follower. Okay, the advantage of such follower is that there is less side thrust. Okay, I will tell you what is the side thrust. So you can see that it is a flat faced follower. The face which is in contact with the cam surface is flat, which we have seen in the video of ice engine mechanism. Okay, so because of this, what will happen? There will be less side thrust. Side thrust means a force which acts along the side of the guides which are carrying the follower. This follower is present in the guides. Those guides are stationary. Okay, and because of this kind of follower, there is less side thrust. You can see that here point of contact is not at the is not passing through the center of the cam. Because of that, the force will act like a little bit inclined. Force will act like this. So because of that, some component of the force will be in the horizontal direction. This force will have side thrust on the guides. So this side thrust is less in case of the flat faced follower. Okay, then there is another type which is the spherical faced follower. Okay, so advantage of this is that there is less surface stresses as compared to the flat faced follower. Surface is under less stress. So here you can see the cam with spherical faced follower. Here you can see that the surface of the follower is of spherical shape. So it is called as cam with spherical shape. Okay. Here next, here you can see that it is a cam. It is rotating as usual, and as it will rotate like this, this is the follower. But instead of having a linear motion, it will have the oscillatory motion like this, angular motion. It will oscillate like this about this point. Okay, then it is a so these are the four types which are based on the type or shape of the surface which is in contact. Okay, now there is another basis on which the follower are classified, that is according to the motion of the follower. So if follower motion is linear reciprocating, it is called as reciprocating or translating follower. Okay, and if a follower have the angular motion, it is called as oscillating or rotating follower. Just in this case, this particular follower is having angular motion like this. So it is called as what? It is called as oscillating or rotating follower. Here the follower is reciprocating. So this follower is known as reciprocating follower. Okay. Next is according to the path of motion of the follower. Okay. So according to it, it has radial follower and offset follower. In radial follower, axis of follower means the path of the follower along which it will reciprocate will pass through the center of the cam. Okay, so here you can see that axis of the follower is passing through the center of cam. So it is known as a radial follower, radial. Okay, because it is in the direction of radius. And second one is offset follower. In offset follower, you can see it is the center of cam. Center of cam is here. Center of cam is nothing but center of shaft. So ये cam का surface हो गया. It is the cam profile, which is called as cam profile. Cam surface is known as cam profile, and this round one is shaft on which it is mounted. Okay, so axis of the follower is not passing through the center of the cam. Center of the cam is same as center of shaft. There is some offset, some distance between these two lines. Then this is known as offset follower. Follower is offset. Okay, and this uh, offsetting reduces the friction or side thrust further. That is the advantage of offsetting. Okay, so these are the three classifications of the follower based on different criteria. Okay, next we will see what is the classification of cams. So if you will refer the number of books, you will find that there is variety of cams based on different criteria. But limiting us to syllabus, we will these two types are very important to us. First one is radial or disc cam, and second one is cylindrical cam. So what is a radial cam? In radial cams, the follower reciprocates or oscillates in a direction perpendicular to the cam axis. Perpendicular to the cam axis. So if you see here, cam axis is here. So your view of the cam axis will be a point view, and this follower is reciprocating perpendicular to the cam axis. Okay, so this particular cam is known as radial cam. Okay, and next one is a cylindrical cam. In cylindrical cam, the follower reciprocates or oscillates in a direction parallel to the cam axis. Parallel to the cam axis. So you consider this example. This is the cam which is in cylindrical shape. Okay, and what is done in this cylinder? A groove is cut. It is a recess is provided in this. Okay, like this. Now in this recess, this follower is in contact with the cam here. So obviously this follower cannot go out of the recess, out of the groove. Okay, now what will happen when this cylindrical cam will rotate? At that time this follower will reciprocate like this, in this way. Means the direction of motion of the follower is parallel to the cam axis. It is parallel to the cam axis. It is known as a cylindrical cam. Okay, so these are the this is the main classification of cam. There are other bases also on which cams are classified. So if you want to go in those details, you can refer the SS Ratan book. Okay, there it is provided. Again, 10 minutes are there, so you have to join back immediately after getting logged out. So
Okay,
till now, any doubt?
no, sir.
Okay. This is
No,
also
sir.
the yes. This is also the example
No,
of.
sir.
This is also the example of cylindrical cam. You can see because the path of the follower is only this much. It is not going to rotate like this. On it will oscillate through a small angle. So you can imagine it to be parallel with the axis of the cam. So it is a cylindrical cam. Okay. So it is about the classification of follower and classification of cam. I will suggest you to refer the Ratan book also in order to study the more types of cams. Okay. Now terms used in radial cam. Okay. So these terms are very important. Okay. You know that the follower takes the motion from the cam by being in direct contact with the cam surface. So obviously the cam surface, which is known as cam profile, is going to decide the type of motion of the follower. Just a second. Okay, so let's start again. So I was telling you the importance of the cam surface. It is the cam surface, and somewhere on shaft you will mount it and it will rotate like this. So it is very important to design this cam surface because based on the geometry of this cam surface, follower will have a particular type of motion, and you can control the motion of the follower, like its magnitude also, that how long it can travel, how high it can go. So it all depends on what? It also depends on the geometry of the cam surface. And in example, in numerical on this topic, cam and follower, you are asked to draw this cam profile so that the follower will have a particular kind of motion. Okay, so in order to draw that, okay, you need to remember this terminology. What is a base circle, then what is a trace point, what is a pitch curve, what is pressure angle, etc. All these terminology which is related with the cam, you should know it. And again, it is the part of your fourth drawing sheet to be covered in your lab. Okay, already we have covered ICR problems, then relative velocity problems, acceleration problem. So these three topics will have three drawing sheets, and it will be the fourth one, right? Fifth one is your mini project. So all the lab part we are going to finish in this week only, because we will be covering the whole syllabus of cam and follower with drawing sheet. Okay, so I may take 3 hours on Saturday, and let us finish it so that next week we will start over the next module. Okay, because so far we have covered only 2 modules. If you go by the syllabus. Okay, so let us see what are these. Okay, so what is a base circle? Suppose it is my cam profile. It is the shape of the cam, and say somewhere here it is the center of cam. So center of cam is nothing but the center of shaft on which it is mounted, right? So what it says, what is the definition of base circle? That it is the smallest circle. What it says? It is the smallest circle that can be drawn. That can be drawn here. One word is missing. That can be drawn tangent, right? So this word should be added here. That can be drawn tangent, okay, to the cam profile. Cam profile is nothing but cam shape, cam surface. So see how you will draw it. The smallest circle which is tangent to this cam profile, cam surface. So this is base circle is drawn taking center of shaft as its center. बेस सर्कल का जो सेंटर है इट इज सेम एज सेंटर ऑफ शाफ्ट. So from this point you have to measure that which point is closest to this point. Okay, so suppose if I measure and if I find that here is the point which is closest to this point, I will take this as the radius and I will draw a circle like this. So this particular circle which I will draw is my base circle. Understanding? Getting it? Concept?
Yes, sir. Yes, sir.
Okay. So base circle. Okay. Next is your trace point. Okay. What it says in its definition, that it is a reference point on the follower. So it is any point on the follower. It is used to generate the pitch curve. Okay, so पहले पिच कर्व का डेफिनेशन है या ट्रेस पॉइंट का. ओके, सो व्हाट इज पिच कर्व आई विल टेल यू. ओके, ट्रेस पॉइंट इज व्हाट? a reference point on follower which traces the shape of the cam profile. Okay, when the follower is moved around the cam profile and cam is kept stationary. Okay, so I will show you what is trace point. See here, now here it is our cam surface, actual physical boundary of the cam, this one. Okay, then we have seen that a base circle is one, it is the shaft, this one is cam shaft. Okay, and it is cam profile. So base circle is the one which is tangent to the cam profile. Okay, and it is the smallest circle. So if I will highlight, so this one, this particular is nothing but the base circle. Okay, it is your base circle. this one. Next trace point is one, the point on follower. ये follower पे एक point है